China built one of the world's most futuristic ports on artificial islands. Yangshan, $20 billion project where robotic cranes, autonomous vehicles, and 5G move most containers. But the most impressive thing isn't the technology. It's the goal of transforming how global trade works. The geographic bet. To see why so much went into this offshore port, just look at the map here. For decades, Shanghai ruled world trade, but Yangtze was problematic. It fueled economic activity, dumping huge sediment loads, leaving nearby waters very shallow. Near Shanghai, depth was often just 7 to 10 meters. By comparison, Singapore runs 15 to 17 meters. Rotterdam keeps 24 meters channels. Shanghai no longer fit modern shipping. In early 2000s, container ships grew bigger. New mega ships hauling over 20,000 containers needed 15-meter draft to dock for safe berthing. Shanghai faced a critical choice: remain in shallow waters and risk obsolescence, or hunt for deep water missing along its coast nearby. The only viable site was about 30 kilometers offshore, a group of small granite islands called Yangshan in the rough waters of the East China Sea. The plan seemed extreme. Build world's largest container terminal on isolated islands, then link it to the mainland by a mega sea bridge. This project was a direct confrontation with geography. Engineers built the 32 km Donghai Bridge to move huge freight daily, enduring fierce typhoons and relentless seas in one of East Asia's harshest marine zones year after year. The project's scale is crucial. Since 2010, Shanghai leads container ports, handling 49.16 million TEUs. In 2024, Yangshan handled 25.7 million that year, 52% of Shanghai's volume total. In short, one offshore site moves more goods than many ports. Unlike city-bound coastal ports, Yangshan was built to expand freely outward. New terminals can be reclaimed from the sea through land reclamation, giving China room to grow beyond the natural limits of its coast. This project didn't just solve a depth problem. It aimed to secure China's long-term place in global trade. With this choice, China didn't adapt to geography, changed it. This choice triggered one of the largest marine land reclamation projects in modern history, turning isolated rocks and open ocean into an ultra-high-tech commercial hub. Engineering the impossible. When Chinese engineers arrived on the Yangshan Islands in 2002, they found steep granite outcrops in the middle of the East China Sea. Small, irregular islands, totally unfit for industry. Building a modern deep-water port meant more than construction. They had to remake the land itself. First hurdle: limited space on site. Natural isles were too small for container terminals, crane tracks, logistics zones. Engineers used controlled blasting to remove granite formations and level the peaks to create stable platforms. But that wasn't enough. To reach required size, China launched one of history's biggest port reclamation projects. Dredgers sucked huge sand from the seabed, pumped it between islands, making new land where once there was only ocean. Phase 1 used about 140 million cubic meters, over 56,000 Olympic pools, but reclaimed land still risks major ground subsidence. If soil keeps compacting after construction, containers and 100-ton cranes may cause uneven subsidence and damage infrastructure. To prevent this, engineers installed vacuum preloading and vertical drainage systems. Thousands of plastic drains were driven into sediment to pull water and air under controlled pressure, speeding consolidation that would take decades. The ground then compacted into a stable base capable of supporting very heavy industrial loads. The port was also designed to withstand extreme weather conditions. Calculations factor Category 4 typhoons, waves up to 8 meters, winds over 150 kilometers per hour. Using East China Sea historical data records, reinforced dikes and tetrapod breakwaters dissipate wave energy, protecting terminals in storms. Precision always mattered. Automated terminal allows no warping. The crane rails and autonomous vehicle paths require perfect flatness over long distances. During foundation construction, engineers used laser surveys and real-time satellite positioning to control elevation and alignment. Final tolerances stayed near 2 millimeters in zones. Essential accuracy for automated cranes on backfilled ground. After stabilizing the ground, terminal work began. Yangshan grew in phases, each boosting capacity and complexity. First 3 set port depth, scale. Phase 4, December 2017, marked a milestone. World's first automated deepwater container terminal. It spans 2.3 million square meters, over 300 soccer fields. For robotic operations, the final key can accommodate up to 200,000-ton container ships at the same time. The invisible architecture. Yangshan's build is impressive, but its key breakthrough remains invisible today. This is Phase 4, the world's largest fully automated container terminal. Here, it's nearly silent, just electric motors humming and cranes slowly moving around today. No diesels, no shouts, no horns. The entire terminal is coordinated by a computer management system called TOS. At Yangshan, the system is called Equipment Control System, or ECS. Developed in 2015 by ZPMC in Shanghai Zhenhua. ECS routes containers, assigns equipment, and manages terminal traffic using real-time data without ground staff. At the site's core, electric EGVs self-guide containers between key cranes and storage yards. With no driver or steering wheel, they navigate using magnetic markers embedded in the ground, combined with a 5th-generation wireless positioning system that provides accuracy of about 3 centimeters. LiDAR sensors continuously detect obstacles to prevent collisions in this dense environment. Automated cranes loom above terminal. In traditional ports, operators work for long hours in cabins suspended dozens of meters in the air. At Yangshan, they run operations from air-conditioned control centers located several kilometers inland. High-definition cameras and sensors allow a single operator to supervise multiple cranes, while most movements are managed automatically. This remote control is made possible by the port's F5G fiber network, whose latency of under 10 milliseconds enables nearly instantaneous control despite the distance. Responsiveness is vital for precise, large-scale container handling. Its strategic value goes beyond automation alone. Unlike many ports using European or US platforms, Yangshan Phase 4 runs on fully Chinese tech, software, optimization algorithms, decision systems built locally, with no foreign IP at all. Since 2020, systems were upgraded, improving planning, throughput, fault detection. China controls the port infrastructure and also the software directing container flows and logistics priorities overall. This automation architecture is being exported to ports in Africa, Southeast Asia, and the Middle East. So key links in supply chains increasingly run on China-designed systems. When a container is unloaded, AI picks the best storage spot based on planned departure time, ship schedules, and land connections. Fast departing containers are placed for quick access, cutting extra moves and delays. The goal isn't just efficiency or cutting human work. It is predictive control of global trade flows, continuously handled by machines that do not get tired. The numbers game. Domination through efficiency. To understand Yangshan's true power, you have to look at the scale. Efficiency isn't a perk. It's the currency deciding who steers trade flows. In 2024, Shanghai moved 49.16 million TEUs, still busiest for the 15th consecutive year since it surpassed Singapore in 2010. This volume sets Shanghai apart from most national port systems. Yangshan isn't just defending its title, it's widening the lead. Big ports like Los Angeles or Rotterdam often face congestion, strikes, and city limits. Yangshan runs for non-stop flow, no urban constraints, no legacy gear, little on-site labor reliance. Since Phase 4 opening in 2017, Yangshan's traffic rose from 10.3 to 25 million TEUs by 2024. Today, this offshore port handles about 52% of Shanghai's volume, 180 million containers overall. One offshore site moves more goods than many whole countries. Advantage isn't about raw speed, but structural efficiency instead. Automated terminals reduce labor needs by about 70% compared to traditional ports. In standard ports, every crane needs a cab operator. At Yangshan, remote operators monitor cranes from control centers. AI handles positioning, alignment, and move order. This setup eliminates one of the main bottlenecks in maritime shipping: human fatigue and shift changes. Operations run non-stop 24/7 despite work, light, staffing issues. In shipping, port time is priceless, since a ship earns only while sailing at sea. Ports cutting weights attract shipping firms. Automation lets Yangshan run loading and unloading with fewer stops, fewer delays, and predictable schedules than manned terminals. Reliability draws ships. Companies choose ports with steady schedules. Yangshan became a key gateway for China's industrial exports, moving loads of electronics, machinery, vehicles, and consumer goods worldwide. This scale advantage extends inland. Yangshan links 45+ cities across 10 Chinese provinces via sea rail network. Containers arriving at the port can be transferred directly to dedicated rail corridors and travel hundreds of kilometers inland without going through congested urban road networks. In a year, Yangshan Sea Rail links carried 840,000 TEUs. Yangshan's efficiency doesn't stop at the coastline. It extends deep into China, reducing lead times across the entire supply chain. Many Western ports face fragmented inland logistics and last-mile gridlock, but China built an integrated system: automated port, rail, and industrial zones acting as one network. This model sparked a global port automation race from Southeast Asia to the Middle East. Governments are accelerating investments in robotic terminals to remain competitive. But China leads decisively. It already runs top ports and also exports cranes, vehicles, and the software controlling them. Global trade's operating logic is increasingly shaped by China-designed systems today. Yangshan is no longer just a port. It's a standard and a glimpse into global trade when efficiency, scale, and control converge in an automated system operating far from public view. Hidden impact and Achilles' heel. One might think that a robotic port in the East China Sea has no effect on daily life. Yet Yangshan quietly sways prices on your purchases. Each minute saved at automated docks cuts delays, storage costs, and price swings hitting consumers. Smartphones, sneakers, and EV electronics all rely on this efficiency. By cutting ship weights and logistics snags, China reduced economists' distance tax. Hidden costs added simply when goods travel far. In 2024, average container rate Shanghai-Los Angeles fell sharply from the extreme 2021 pandemic highs seen then. Many factors drove the drop, but port efficiency, improved reliability, and eased trade hub jams. So a product made far away can arrive faster and cheaper than one made nearby. But convenience hides costs for us. The world economy relies more on few automated ports. When they dominate, overall resilience drops fast. Yangshan automation shifts eco trade-offs. Phase 4 uses EVs to move containers, cutting terminal diesel. But the impact stays complex and hard to gauge. China's grid still runs on coal, limiting overall emissions gains today. Outside the terminal, Shanghai began tests of autonomous container trucks in select ports. Tests suggest long-term gains, yet full commercial rollout still faces regulatory, technical, and safety hurdles like autonomous vehicles worldwide today. As Yangshan strengthens its role in global trade, questions arise. Have we traded industrial independence for faster, cheaper shipping? This port is a strategic bet on a future where geography weighs less in economic power. But dependence also means vulnerability. Yangshan's biggest strength, total reliance on centralized digital systems, is also its risk. When software coordinates every crane, vehicle, and container, disruption needn't be physical. Cyber attack, IT failure, or geopolitics can ripple far beyond the port. Tech still can't fully shield Yangshan from nature. Built on reclaimed seabed, the port faces harsher storms and rising seas each year now. These dikes and breakwaters were designed for past storms, but climate models predict even rougher East China Sea conditions. So, it's not if Yangshan will be tested again, but whether engineering, IT systems, and geopolitics can withstand pressure simultaneously. Yangshan could remain a monument to human ingenuity or reveal its fragility, with a single disruption enough to show just how much the global economy now depends on a silent, automated, artificial swath of ocean. This port marks the moment when port automation moved from experimentation to a large-scale reality. Its success has forced ports from Singapore to Rotterdam to accelerate their automation to remain competitive. China now holds an edge, not just through Yangshan, but by controlling much of the machinery and automated systems used in ports worldwide. Chinese-made cranes and software are steadily becoming the backbone of maritime infrastructure. Yangshan matters structurally, not symbolically. Whoever sets goods, shipping standards controls global trade's cost, speed, and reliability for everyone today. Today, this standard is called Yangshan.